This lecture video is about solving exponential functions. So exponential functions, remember, have the form f of x equals b to the x. And so we're going to take a look at if you have some number raised to a power is equal to that same number being raised to a power. If that's true, then those powers have to be equal to one another. And so that's the form of equations that we're going to be looking at today. So when we start out, they're not going to look that way, but we have to make them look that way. So right now, 3 raised to the x is equal to 9. So the base on the left is 3, but the base over here on the right is a 9. So we want to write this so that we have 3 to the x equals 3 raised to some power. And remember that 3 squared is equal to 9. And so instead of writing a 9, we're going to write it as 3 squared. And now the bases that we have are the same. And so we know that the exponents have to be the same as well. And so x is equal to 2. In our next example, we have 4 raised to the x is equal to 1. So again, we need 4 to the x here on the left. And we need to write 1 as 4 to some power. Well, there's a property that says that no matter what number you have, if you raise it to the 0 power, it's equal to 1. So we could write this as 4 raised to the 0 power, and that would give us x equals 1 or 0. On our next example, we have 5 raised to the x is equal to 125. So we have 5 raised to the x, and we want to write 125 as 5 raised to some power. And 5 squared is 25. And then if you type in 5 cubed on your calculator, you'll get 125. And so we would write 125 as 5 cubed, and so that gives us x equals 3. In our next example here, we have 1/3 raised to the x equals 27. And so we want to write 27 so that it's 1 over 3. So the way that we're going to get the number down into the denominator, instead of right now, so 27 is like 27 over 1, so we really need this number to drop down into the denominator. And the way that we do that is raise it to a negative power. So we're going to raise it to a negative power. That's going to take the 27 and flip it upside down. So 27 raised to the negative first is the same as 1 over 27. But we don't want a 27 down there. We want a 3. So the next thing I need to figure out is 3 raised to some power gives me 27. And what power is that? Well, 3 squared we saw before was 9. 3 cubed, though, is 27. And so, and again, this negative power is going to make the number be down in the denominator. And so we would want this to be 1/3 raised to the negative third. And so now this will give us 27. Because the negative sign flips this upside down, giving us 3, and then we would cube the 3, giving us the 27. And so now that our bases are the same, that tells me my exponents are also equal, so x is equal to negative 3. Okay, the next example here, we have 4 raised to the x equals 32. So again, we need these bases to be the same. And so we're going to try to raise 4 to some powers and see what we get here. So 4 squared gives us 16. And what do we get when we take 4 cubed? Well, that's 4 times 4 times 4. 4 times 4 is 16. And then when I multiply 16 by 4, I get 64. So you see we went right by this 32, and so we're going to need to rethink this a little bit. So I can't use the 4. We need to rewrite both sides now. And 4 is 2 times 2, or 2 squared. So the 4 is the same as 2 squared, and that's being raised to the x power. And we can write 32 as 2 raised to some power. So 2 times 2 gives you 4, and then times another 2 is 8. And 8 times 2 is 16. Oops. And then times another 2, 16 times 2 is 32. So that's what number is going to do it for us there. And so that is 2 to the 5th power. So when you have a power being raised to another power like this, we have the 2 being squared, but then we're taking that whole thing to the x power. You multiply those exponents, so that's the same as 2 raised to the 2 times x, or 2x, and it's equal to 2 raised to the 5th. And now we can set our exponents equal to each other, so 2x equals 5. Divide both of these sides by 2, and we get x is equal to 5/2. Okay. So now our next example, we have 4 raised to the x plus 2 equals 64, and we just went through the powers of 4, so we can get 64 from raising 4 to the 3rd power. So we have 4 raised to the x plus 2 is equal to 64 is 4 cubed. And now we can set these exponents equal to each other. So x plus 2 is equal to 3, and when we subtract 2 from both sides, we get x equals 1. And now for our next example, we have 1/8 equals 2 raised to the 3x. So now I want to write this 1/8 so that it's 2 raised to a power. And first of all, notice that this 8 right now is in the denominator. I need that 1/8 flipped upside down, which means that this needs to be a negative power. And also, we need this to be 8, and 2 cubed is what will give us 8. So this is 2 raised to the negative 3rd. So the negative sign will flip this upside down, giving you a half. And then when you take a half times a half times a half, you get the 1/8. Okay, so 1/8 is the same as 2 to the negative 3rd. And then that's equal to 2 raised to the 3x. And so we have the same base. And so we can set our exponents equal to each other. So negative 3 is equal to 3x. And then divide both sides by 3. That gives us x is equal to negative 1. And in our next example here, we have 2 raised to the 5 minus 3x equals 1/16. So again, we want to rewrite this 1/16 so that it's 2 raised to some power. The negative sign is going to flip the 1/16 upside down, and 2 to the 4th is what will give you 16. And so set our our exponents equal to each other. So we have 5 minus 3x equals negative 4. And solving this for x, we would subtract 5 from both sides. And that gives us negative 3x equals negative 9, and then divide by negative 3. And that gives us x is equal to 3. And that finishes our lecture on solving exponential functions. Let me know if you have any questions. Thanks.